Thomas from Express Unity, and today we're going to be continuing our Tnet little mini-series. I did say in my first one that I was going to be doing 4 episodes, but I ended up getting really busy over Christmas, which I didn't really want to do because I wanted to make those videos. So instead, I'm just going to finish off these 4 videos that I have planned. And then I'm going to jump back into that survival series, as that's probably got 4 or 5 episodes left until I'm happy to leave it where it is. Okay, so the first thing that I want to do is basically spawn in a player. Now, I do want to just give a big thank you to everyone who has subscribed. The channel has grown pretty big. I mean, I never thought I was gonna hit 1,000 subs this fast, to be honest. But yeah, we're like 50 subs off. Not sure what I'm gonna be doing for the 1,000 subs. Maybe some kind of event, maybe a game jam. Not sure. I'm still trying to figure that out. But anyway, as a quick thank you, I've gone ahead and just made a simple UI pack just for this tutorial. So I'm going to chuck this inside of the free assets area of the Discord. And if you wanted to use this to follow along or just use this in your own commercial products, that is fine. Alrighty, so the first thing we want to do is create a player. So I'm just going to create an empty object. I'm going to reset the transform. I'm going to call it player. And I'm now going to create a, what do we want? Let's go for a capsule. And let's just call this graphics. And let's just tag it player. Alright, cool. So just to get things started, I'm going to create a very basic movement script just so we know everything's working. So inside of our client folder, I'm going to create a player folder, and inside of this, I'm going to create a player movement script. And once again, Visual Studio doing its weird thing. So yeah, let's just set up our player here. Drag our script in, and you know me, I like my rigid bodies, so I'm going to go ahead and do that. And I'm going to freeze all of the rotation. And just to get things started, let's create another cube, and this will act as our ground plane. And we are going to reset the position, and we'll just make it a little bit larger. And we'll just move it below where the current player is, as just for a start, we're going to spawn all the players at vector 0. Now, just to make this a little bit easier to look at, I'm going to create a few materials. We are going to create a ground material. And we'll make this like a dark gray. And we will give it we're gonna have a 0.7 with the smooth, and we'll go and make one for the player. And to start with, let's make it blue. What we're going to do is basically we're going to color our player depending on who we are, basically. So gonna go third person. If we are the current player, we will be blue. Otherwise, all the other guys are gonna be red. So yeah. Okay, and we are going to create a little, basically a little point that the camera is going to follow. So I'm gonna call this camera point. And this is kind of just a quick hack to quickly get a camera follow script working. It's not really an ideal way. I mean, depending on your game, really. But yeah, we'll position it like this for now, I suppose. And let's get some basic stuff happening. So the first thing we want is a public transform. This is going to be our camera point. And next we just want... Oh yeah, first what we should be using is Tnet. And we are also going to be wanting to inherit from TN behavior. This now gives us the functionality of TNO, and this is like Photon's view variant. So we can do TNO stuff like is mine, and a few other things we can get from the player, like their channel ID, full ID. It's basically the Photon view, if we're thinking of Tnet like Photon. So basically in the update, we're just going to say if tno.isMine. And now in here, we can start doing our basic movement things. So I'm just going to create just some changeable keys. So key code forward, public key code backward, public key code left, public key code right. Okay, so now we're just going to make some things for our inputs. So if input.get key, and we want to get the forwards moving key. Gosh, excuse me. Okay, and now we just want to get a rigid body. Whoops. Rigid body, we'll call it RB, and we'll just say RB equals get component rigid body. Alright, so for forwards, we're just going to say RB dot, we want to add relative force in the vector3.forward direction, and we are also going to create another variable just above here, and we'll say public float speed. We'll have different speeds, so we'll call this move speed, the other one's going to be rotate speed, and we're just going to create a quick header up here just to tidy things up, and we'll call this our movement settings, or rather our movement bars. Doesn't matter, whatever you want. Up here we could create another one that just says camera vars. Camera cars, yes, camera vars. Just for variables. Okay, so now we just want to times this by our move speed times time dot delta time. So now we're just going to do this a couple more times. So now it's just going to be backwards. I think we can do vector3.back. This is going to be left, so we can do vector3.left. This is going to be right, so we can do vector3.right. Okay, so now we just need to make our simple camera follow. So underneath all of this, we're just going to say camera.main.gameObject.transform.position equals vector3.lerp, and we want to lerp from the camera's current position to our camera point, and we'll make it somewhat snappy, so maybe to float by time dot delta time. We want to do dot position. Alright, so this should just be a basic movement script. Make sure this the camera lerp thing is inside isMine as well, otherwise you might have some funky stuff happen with the camera. So that is good. We should still be able to test it because we haven't added a TN object onto the player, but we will get an error. Just want to make sure everything... Okay, so the camera is snapping to it. We don't have speed. Let's just add maybe like 30. Okay. Oh wait, we haven't set our keys either, so we'll just try that. Okay. So speed 1000. Forwards will be W. Backwards will be S. Whatever that is. There it is. Left will be our A key. And right will be our D key. Now, benefit of doing things like this is you can make a settings panel and people can choose whatever they want, really. So now we want to create a TN object, and basically we want to leave it at 0 because this is going to be something that spawns in. If we assign a unique ID, that's basically going to make it a scene object. So for example, maybe we want to have some static boxes in the scene that we want to synchronize their movement with all the players, or maybe some sort of chest that is just static for every level. Then we would want to assign a unique ID to that. Alrighty, so just like for Photon, we now want to create a resources folder. And inside this resources is going to be our player. And for the time being, we are going to disable the current one. And inside of our connector server, when we join a channel, we want to instantiate our player. So how we do that, this is a little bit different to Photon. So we want to call tnmanager.instantiate, and this first parameter is our channel. So by default, we are just going to say .last channel ID, and this next one is an ID to our function. So I'll show you what I mean in a second. Or we no, let's just set it to 0 because we'll do a function name first. So this is going to be our function name. So we'll call it spawn player. And then the next one is our player name. So I believe we just called it player. And then this next one is if it's persistent or not. So persistence basically means if we disconnect, is this object going to continue to stay connected? And the answer to that is no, because if a player disconnects, we don't want their object to stay. There are instances where you might want this. For example, if you're making an MMORPG and someone's trying to avoid some sort of PvP situation, if they disconnect, you then make some sort of logic for that object where the object will stay there for, I don't know, 10 seconds before it actually leaves the realm or something like that. But yeah, so that's our instantiate. However, this will not work at the moment. We need to do some special stuff for this all to work. And it's kind of... It is kind of more work than Photon. As Photon, you kind of just place this in and you're kind of done. However, I feel like doing things the way Tnet does gives you some freedom with how you spawn your objects. So what we want is, first we want to create a static game object, and we want to call this spawn player. And the first instance is going to be the game object, which is the prefab. And the second is going to be a vector3 with our position. Okay, so alone this won't work. What we need to call is an RCC above it. And what RCC stands for is remote creation call. We also have RFC, and that is remote function call, but we'll get into that one a bit later on. So what we want to do now is basically just create a game object. We'll call it G, and this is going to be equal to prefab.instantiate. And now we're going to say g.transform.position is equal to position. And we are simply going to return G. Now, we have one parameter that is automatically filled in by the instantiate. However, we have a second, which is not a default parameter. This is our position. So after our persistence, we now have our parameters objects. And all we're going to do for this is say new vector3, and, or rather we could just, to make things easier, say vector3.0. So this is just going to pass in our vector into this function, and then this function returns our game object back to the instantiate, and we have our player. Alrighty, so we should now be able to spawn our player when connected to the server. So we did nothing to the server, so we should be able to so we go here and we'll just start the server up on my other screen. Okay, there it is. So if we join, we should connect, and we will also, yep, we now spawn in, and we should be able to move around. We're not moving to the right, apparently. Okay, well, we can move everywhere except for right. So let's quickly see what's happening in the player movement. Oh, okay. I don't know what I did here. That needs to be outside here. Okay, there. Alrighty, so that is cool. Now we have our spawning of the player working. We're gonna make some quick little rotating scripts. How am I gonna do this? I'm not sure. Let's do this. So float x equals input dot get axes, and this is going to be mouse x, and basically we're just going to say game object dot transform dot rotate and new vector3, and we're going to pass in x, and the rest is just going to be 0. So now when we connect, we should be able to move freely. That's a server, this is Unity. Alright, wrong axis. I'm really good at that, guys. I don't think there's been one video I've made so far where I've actually gotten that right first go. Okay, let's try this one. Okay, so it is working. There is one thing we missed on the camera though, is not only do we want to lerp the position, but we want to lerp the rotation. So dot rotation, we then want to say quaternium.lerp. First one is going to be the camera rotation. Second is going to be the camera point rotation, and we might want the rotation to be slightly faster than the position. So that should be good. Should now be able to rotate. There we go. Move around and rotate. You can see why this method of moving the camera isn't quite there. We could even maybe slow down the rotation a little bit. I mean, it's no. Might end up speeding everything up. So maybe position of 4, rotation of 6. This simple method, but you know, it'll suit a particular style of game. But you know, there we go. It's okay. We know what we're doing. We know we're blue. Quick thing to smooth it out just a little is for the interpolate. Just set that to interpolate, and the player should now be slightly smoother than it was. So there we are. Little bit better, tiny bit. But that'll do. So we should be able to just no, not yet. We can't test. We can test if it spawns. It should work, but we have no way of sending positions to each other, right? So this is where we create an RFC call. So I'm just gonna say something like public void sync rigid body. We're gonna pass in a vector 3. We're gonna pass in a quaternium. We're going to pass in another vector 3 for the velocity. The first vector is also going to be a position. And another vector 3 for the angular velocity of the rigid body. So all this is going to do is say rb.position is equal to position, rigid body rotation is equal to rotation, rigid body velocity is equal to the velocity, and rigid body dot angular velocity is equal to the angular velocity. Alrighty, so now we get into Tnet's variety of an RPC call. Oh yes, and we want to make this an RFC, and we can call both the RCC and the RFC with an ID, so we can give it an ID, and instead of this, we can do that. But since we're only calling one RCC in the connect to server, we don't really need to do that. Whereas because we're planning to have multiple RFCs, it is best to give them an ID over naming them. I found sometimes if you just name them, for some reason Tnet clashes with itself and you'll get errors where it's calling another RFC when you want another one called instead. So just give it an ID. I found it works way better. Alright, so basically inside the Tnet is mine, we now want to say tno.sendQuickly. Send quickly basically means it does not care if the packet is lost or not. If you want it to wait for a packet, you then use .send. But we're just going to do send quickly. Alrighty, so the first one is our ID. And next we're going to say target.others saved. What that means is if another player joins the server, it's going to push all the or the last RFC rather to the client that joins, so that it gets all the correct position and velocity and any other data we want. Now we just want to send our current rb.position, then our rotation, then our velocity, and then our angular velocity. And that is it. We have made our first RFC call with Tnet. Now RFCs, just like I said, are basically Photon's RPC variation. So whenever you want to do something in Tnet that is similar to an RPC in Photon, you always call it an RFC. Whenever you want to instantiate a networked object, you always call RCC. Okay, hopefully that wasn't too confusing. So just save this, and we can quickly test to make sure there is no errors when our client instantiates. Doesn't seem like there are errors. Okay, let's give this a save and a build and run. Oh, actually, you know what? I'm not sure if let's just quickly cancel that. Go to our build settings and make sure that we are in fact building the client. And we don't even have the scenes added. So we want to add our client and the server. We want the server to currently be disabled. And that should be it. We can now build and run. And we'll create a new folder called client. And in here is where our build is going to be. Oh, and we left server build on. We want to uncheck that. Oops. Alright, now we can build and run. So whenever we're building for the server, we want to enable the server scene and enable server build. Server build isn't really required, however, the server doesn't really need to draw anything graphical. Unless you want to make some sort of spectating system where you can view everything happening on the server, but that will in turn use a lot more resources on your whatever server you're planning to purchase for something commercial. I will recommend just putting it in server build so that it doesn't need any graphical processing at all. It is just a server and it does whatever calculations it needs without any graphical display. So again, because we're using basically the C++ or C# to C++ compiler for Unity, and this is the first time we're building the client, it's going to take a little bit to compile the project. Create exception. Okay, hopefully that didn't stop any network connection. So let's join with this one. Whoa, okay. There we go. So the reason why that happened is because before the RFC could be called, we basically spawned inside each other, making the rigid body of Unity go a little bit crazy. But you can see we're now synchronized. We can move. I can go into the other player, move the other player. Now, this is not auth movement. I think Photon's default movement script, that is somewhat authed, because if I go onto this other player, I can actually push the other player around with no penalty. And in this one, I can do the same. So it's not only the owner that can push another player, it is both players. Maybe that's something you want in your game, maybe it's not. For now, we're just going to be doing things very basic and simple. And on the last episode, I will show you guys how we can basically get some authoritative networking happening, where basically the client will message the server. It'll say, hey, I want to move. What speed can I move at? And then the server will basically send a value of the speed that he can currently move. So yeah. Thank you guys a lot for watching. Hopefully you guys learned a little bit about Tnet. Hopefully you guys are enjoying the Tnet series. And let me know in the comments below if anyone is actually or has actually purchased Tnet and followed along, if they're enjoying Tnet itself. I find Tnet to be more indie friendly over Photon, as it's just in the long run, Tnet is just going to be cheaper, right? Because if you're starting off small, maybe you have a community of only 200 players, the one or two high-end VPSs at like $15 a month are going to be more than enough to support that. And then yeah, you can just keep expanding your servers, and I just feel like Tnet is a better option when you're just starting off in multiplayer. So yeah, if you guys had, I can't remember if I linked my VPS company that I used in my previous video, but I will link it in this video if you want to check them out. They're super cheap. I think I'm currently paying like $12 for a Windows VPS that I run a server for Tnet on, which I do all my testing with. But I mean, I've had up to 15 players on one of their servers, and it handles it just fine. So So yeah, again, thank you guys for watching. Leave a like, subscribe, and I'll see you guys in the next Tnet video.